Welcome to Pete Smart. How can I help you?
Well, if it isn't my old friend Pete Mullen. I didn't know you worked here.
Technically, I don't, but I'm filling in for the other Pete while he's on vacation.
Wait, Pete works here?
Yeah, but not just here. I didn't realize what a huge job I was agreeing to. Besides working here, Pete also has shifts at Hilbert's Hotel and the paint store, and he helps the Oracle with their Costco run on Sundays.
Wow, that sounds like a lot.
It's definitely keeping me busy. So, what brings you to Pete Smart?
Well, with Pete gone for a few episodes, I thought I'd check out what kind of selection you have here.
Selection of what?
Of Pete's. What better place to find a temporary co-host than Pete Smart?
Okay. You know how you can't just walk into Target and buy archery equipment?
Huh?
They don't sell targets at Target, just like they don't sell crates or barrels at Crate and Barrel. And believe it or not, you can't just waltz into 7-Eleven and buy a couple of prime numbers.
I'm not following you.
Just because the store is called Pete Smart doesn't mean we sell Pete's. I mean, come on, for Pete's sake.
Well, why is it called Pete Smart then?
At the moment, I'm really starting to think it's because out of the two of us, Pete's smart.
Haha. Hey.
What?
Your name is Pete. You're smart. And you clearly have an overabundance of free time.
Well, I wouldn't say.
How would you like to co-host an episode of the Math Club with me?
You mean substitute for Pete and get another one of his jobs while he's gone? Sure, why not?
See? This did end up being a good place to come for a new Pete after all.
I guess so. And speaking of substituting, I even have an idea of what we can talk about.
Hey there, everybody, and welcome to another episode of the Math Club. As you probably know, our regular co-host, Pete Littig, is on vacation, and we have in his place Pete Mullen filling in and co-hosting an episode. Welcome to the Math Club, Pete.
Thank you so much. It's great to be here.
Before we get into our actual topic for today's conversation, why don't you introduce yourself and tell our listeners a little bit about your background with math?
Well, my name is Pete Mullen, and I think I've actually been friends with you longer than Pete Littig, which is quite a long time.
Some might even say too long.
I'm sure some people would say that, yes. Well, my story with math is long and complicated. I'm dyslexic, but for a long time when I'm diagnosed, these things were just not as well known back in the early 80s, so my teachers really just did not know what to do with me. It was strange, too, because I wanted to read so badly because my entire family was always reading. So when I went to school, I learned to read, but I could barely write things down. Turns out that I was a contextual reader, so my brain just learned what I was reading. And all of the scrambling up of letters just did not matter to me. I could fill those words in. That did not work with math, however. If you read that problem wrong, your answer is just going to be wrong. I finally was diagnosed when my parents brought me to a specialist who put me through some really intense training over one summer. And I sort of got over it. They basically had me trace circles forwards and backwards, write out P's and Q's a ton of times, and pretty much ruined a good part of the summer after fourth grade. Eventually, I graduated with an undergrad in political science, and then I decided to try to copy you and be a teacher.
Well, copying me sounds like a worthy life goal, if ever I heard one.
It really is. And this is where life taught me a lesson. Yes, teachers are needed, but math teachers are really needed. So I went back to school and learned some math and found that it was far more interesting than it used to be. I had really learned a lot about my disability by then, and I was better at dealing with it. Soon after, I moved into technology.
Now, wait a second. If memory serves, I think you mean you were kicked into technology.
That is very true. My wife really wanted to start a family, and that takes money. So I moved into technology, and I've been there for over 20 years now, programming and designing software. I use math all the time in what I do, but I also use all the skills I learned as a teacher A lot of what I do today is help people move their applications to the cloud. And since that is a new skill set, I spend a lot of time educating people about how things work. So while that road was windy, in the long haul, all those skills came in really handy.
Yeah, I'll bet. Now, at the end of our opening sketch, you mentioned that you had an idea what we could talk about today. So what is it you'd like to discuss?
When I went back to math, one of the things that actually really interested me was the idea of substitution and how we kind of group patterns of numbers together to actually perform more complicated functions.
Okay, so you're not just talking about substitution as in you are substituting for Pete right now. You're talking about mathematical substitutions to help in solving for variables.
Yeah, correct. And most of us are introduced to substitutions through systems of equations. And this is done in Algebra 1 or Algebra 2, where we see two problems. And basically, if you were to graph the two functions, they would actually intersect at a single point or not, as the case may be. But when they intersect, the systems of equations has a solution. That is one way to solve the systems of equations, is to graph the two lines and see if they intersect.
So when you say that one way to solve this would be to graph them, what you mean is we could take both equations, graph them on the coordinate plane, and where those two lines intersect each other, that's going to be a solution that satisfies both equations.
Close your mouth and open up your heart and baby, satisfy me. Satisfy me, baby.
Is that what you mean?
Exactly. So if we were to take two functions, y equals negative 2x plus 5 and y equals x minus 1, right? We're keeping them in y equals mx plus b to make things easier. We can see that we have a line that has a y-intercept of 5 and a slope of negative 2. And then the other one, we have a y-intercept of negative 1 and a slope of 1. Now, those happen to intersect at the point 2, 1.
And I believe what that means is if we graphed both these equations, we would actually physically see that that's where the lines cross, is at the point 2, 1. And that would also tell us that if we plugged a 2 in for x in either equation, the value of y that that function would give us would be 1. Both equations where x is 2, y is going to be 1. Is that what you mean?
That's exactly what I mean. And if we think about what a graph represents, it's all the possible x, y values. So where they intersect, obviously, the x and y values have to be equal.
Well, that makes sense. Now, how would you use substitution to solve that same system of equations without having to graph it?
This is the part where I think it gets really cool, because graphing is the fairly obvious thing. But when I first learned substitution, I was not very gifted at math. This really kind of blew my mind that what you really did is you basically took those initial things and you said, y equals x minus 1. So you went back to the other function and you simply replaced y with x minus 1, saying these two things are both true. So if y equals negative 2x plus 5 and y equals x minus 1, then x minus 1 equals negative 2x plus 5, and you can simply solve that.
Okay, that makes sense. And it's funny because you used the word replace the y, but what you are actually doing is substituting the other value for y into the second equation, which is why we call it substitution.
Correct. Sometimes using different words, I think, helps people's understanding. So that substitution method is a really good introduction to something that becomes far more important in math as you move forward. It becomes important in algebra and even in calculus, this idea of substituting something and then performing an action and then bringing things back in is all throughout mathematics.
Okay, so now that we've looked at sort of the most basic example of substitution, can you give us an idea of a more complex situation where this same strategy would be helpful?
Sure. Before we move on to more advanced, there's other places in algebra where substitution is used. So if you had something where you had x plus 3 squared minus x minus 1 squared, you could actually substitute another variable for x plus 3. And what's really neat about this is that if I had the x plus 3 squared and I replaced it with just u, or substituted it with u, that just became u squared.
You talking to me?
And the second one I had was x minus 1. Now, if you think about x plus 3, and if I substitute in one variable for x minus 3, that becomes u minus 4, because of course 3 minus 4 is negative 1. So I substituted things in and I simplified it. In that example, the second parenthesis still has two characters. The first one has 1. And I can work with that and I can simplify it. And then at the very end, I can substitute things back in. Now, if I go through it step by step in a podcast, it's going to be easy to get lost. But the idea of taking something complex, saying, I'm just going to actually group things together in a pattern and put in a substitution variable and then bring it back in, that's the main idea. And that's a really powerful concept in math.
I get what you're saying, but I have a question. When you substitute, for example, the variable u for x minus 1, is that only helpful because it makes the equation shorter and easier to write and easier to look at? Or is there another reason I might not be thinking of where it's actually easier to solve?
Well, I can't really say that I know of problems that you can't solve without substitution. However, there are some examples that would make problems very hard to solve without substitution as you move forward in math.
How so?
Well, even if we stick in the area of algebra, there are problems that are very big and would take quite a bit of time to solve, and substitution can make them much easier. You simply eliminate a lot of the steps using substitution. But for me, it became a lot more obvious in calculus that I had to use substitution or I was just not going to get to the right answer.
Do you remember a specific example?
Well, in the first calculus class, you spend a lot of time learning about derivatives and integrals, but you're only working with the very basics to learn those concepts. But when you get to your second calculus class, you get to a place where you have to start working with complex integrals. Now, I'm not trying to scare anyone, but these were pretty hard for me. Sometimes the calculations can just take a page or more to get to the right answer. But then after you really kind of go through things a bit, they start to teach you some techniques to make it easier. Just like we did in our algebra problem. We skipped the hard part by using substitution. Now, the technique that stuck with me the most was trig subs. When I took calculus, it had been a long while since I had taken trig. You remember taking trig with me, right, in high school?
I do remember that. And what I seem to remember most is that our teacher used to let us try to shoot a wadded up ball of paper into a plastic cup he'd stapled up on the wall across the room. And if memory serves, you got yourself eternally banned from playing that game because of a sore loser moment you had when you missed.
Missed? That shot was in that darn cup. And at that very moment, gravity stopped working and it came back out.
Oh, Maybe Pete can explain the math of how that would work to me when he gets back.
Well, the sad thing is that game is what I remembered the most from that class too. And I needed those trigonometric functions that I was in calculus class. Because as it turns out, you need to know your trigonometric functions to perform trig subs.
So this is your example, something that you can't remember?
Well, trig subs really stuck with me because I had such a problem. I had to go and relearn those functions over one weekend.
Oh, so you do remember them now?
No, I worked so hard to get past that point that the concept really stuck with me. All the trigonometric functions follow a specific pattern when you integrate them. The key is to be able to recognize a function that is close enough to a specific type of pattern. Once you do that, you can use your algebra skills, including substitution, to get that function to look like a trigonometric function. And once you do that, you can follow the pattern to get past the integration. After you're done with the integration, you're past the hardest part of the problem. You can sub things back in and move on.
Okay, so let me try to clarify. Is this essentially what you're saying? That you might be doing some pretty complex calculations, like, for example, with all of these big polynomials, stuff like 5x cubed plus 8x squared plus 2x, and you have to multiply this monster polynomial by other things, or square it, or do all these other calculations with it. And we all know it's a lot of work to multiply polynomials or to perform other calculations with them. So you can just substitute one variable for the whole expression. Just call it U, like you said before. And now all those calculations become so much simpler with just the one little variable. You can multiply by it, you can square it, all that. So much easier. As long as when you're done with your calculations, you remember to replace your original polynomial back in for the variable that you were using as a sort of temporary placeholder. Exactly. Now, substitution won't help you with every single problem, but when you have repeated patterns in your problems that you can group up and then substitute in a single variable, you're usually going to make things easier for yourself. And this is an important concept because I believe that people who learn from an early age to use different techniques to solve problems really benefit when they get to this level of math. Instead of following a strict algorithm to find the answer, they learn to be creative and use techniques to make math easier for them. Learning the art of manipulation and trying different ways to solve problems is a very powerful lesson for math students. It took me a while to realize the power of substitution techniques and how cool they are in terms of an almost new way for students to think through solving problems. You know what this is kind of reminding me of, Pete, is when I teach elementary school students basic arithmetic, like, for example, addition, sometimes they'll see a problem that they can't quite do in their head, like let's say 27 plus 18. But something I'll show them that they can do is they can substitute a simpler number in place of one of those two. So instead of doing 27 plus 18, they can do 30 plus 18, because that they can do in their heads. They know 30 plus 18, that's 48. They just have to remember when they're done that, wait a minute, I substituted a number that was 3 bigger. So my answer is now 3 bigger than it's supposed to be. So I need to take 3 away. Instead of 48, my answer is 45. Even though this is a much simpler example, is this kind of getting at the same idea of what you're talking about with these trigonometry substitutions? Yes, it's the same idea. But there is more to what you are teaching your students. By using that simple method to make that problem easier, you were teaching them that foundational art of manipulation that I'm talking about. They don't have to solve that problem as it is written. They have the freedom to manipulate the problem correctly to help them get to the right answer. That is a foundation that will help them learn so much as they move forward in math. Think of it in layers. You learn to use more creative techniques with addition. Seems so simple, but later on, they'll have to start to work with fractions. Fractions require a lot of manipulations to solve, so they're already used to this manipulation. Then when they get to algebra and later calculus, they're using this more and more. So you're helping them really build their creative approach to math. Manipulation is not just a shortcut. It's a critical math skill. And not only is it a critical math skill, but it's one that kids have a pretty easy time getting their heads around, at least at first. They really can see why when I substitute a 30 for a 27, it's easier. But then I have to remember at the end to do a little bit of work to undo the substitution. Exactly. And it's easy for them in the lower grades when kids are in grade school. But when we look at that year that is like pre-algebra, algebra, and how many things we're introducing to them.
Allow myself to introduce myself.
If they don't already have that idea in their heads, they have a hard time because they're following this algorithm, especially with substitution. A lot of students are truly grasping the manipulation of this. And it's really important in algebra to understand that, hey, you know what? You learned at the beginning of the year that X could equal some number. And that was a conceptual leap for you. But what we're really doing when we start with systems of equation and substitution is saying X just may not be a number. X may be a whole nother function. X can be anything. And we can start to actually bundle and make our own variables by grouping together parts of problems to make things easier for us. That is a huge conceptual leap for students in those grades. And I wanted to say, I'm sorry, it took me a long time to make. Yeah. I don't even know if I ever got to that point where I was substituting an entire function for a variable. Well, you were, right? With the substitution method. When we said X equals these things, you were basically saying, here's two functions, right? And you were substituting in the value. You said Y equals X plus 5. And then when you took out X, that was a function. You were taking two functions and you were combining them. Oh, that's a good point. Yeah, you're right. I guess I did do that. I just didn't realize that's what I was doing. Yeah. And so my point is why this has become kind of a really interesting thing for me when I went back and I taught this for a little while is
I realized, because I had gone through calculus and I really had to understand this, that, wow, you kids need to understand that this is a big concept for you and it makes things easy for you. And I use substitution all the time to make math easier for me. One of the things that I know you talked about in a previous episode with order of operations, when you were talking about division and everything and multiplication, I actually constantly make things the same. If I have multiplication and division, I transform it all to multiplication by just, flipping over. If I have a division problem, I flip it over and multiply, just like you can flip over any fraction. And so I always do that. So I never have to think about order of operations. I just make it the same operations through using a little bit of substitution, and I can solve it much easier.
That's a great idea. I don't think I ever thought of that before. Just go through and sort of level the playing field all the way through your equation, and then it becomes much easier to evaluate.
Exactly. And then no matter how you do it, you're always going to come out with the same answer, because once you have the same operation, the associative property applies, and you no longer have to think about things quite carefully.
Yeah, that's really neat. Are there even more advanced examples that come up even further along someone's mathematical journey in the more advanced areas of mathematics where substitution really comes in handy?
Well, other Pete is probably going to have a lot more examples about higher math. But if you don't mind, I'd like to take a bit of a turn and expand our subject.
Expand away.
So as we've been talking, I realized what I love so much about substitution.
We love these songs 'cause they are good to us.
It's really about manipulating problems so that they're easier to solve. And we can talk about that in a different context. So let's take an equation with fractions in it. Say 1/3 y equals 1/4 x plus 6. Now, I homeschooled my boys in math. And when we started to work with these equations with fractions in it, they would start to move things around and start to work with them. And I would just stop them and say, multiply both sides by 12. If you don't want to work with fractions in your equations, don't do it. You have the freedom to do whatever you want to do to both sides of that equation. So why not do the thing that makes it the easiest? So 4y equals 3x plus 72. It's just a far easier problem to work with.
Yeah, I remember doing that in algebra.
Yeah. And that thought process is very similar to substitution. You're manipulating problems so they are easier to solve. Substitution is just another tool in your kit to manipulate those expressions. But instead of simply multiplying, you're actually grouping up items and substituting in a single variable for them. When you simplify complex algebraic expressions, substitution can be used all over the place. But when we teach algebra, you have to realize that we are focusing on one area at a time because you're learning a lot of skills. So we don't always teach students how to manipulate the problems to get around certain areas because we want them to learn how to solve those specific areas because you can't always get around it.
Learning to manipulate your way around certain lessons would make teaching the lesson harder.
Yeah. So while we do learn these techniques, we're not always applying them as we go through our math journey. But for those who are learning, I think it's really important to realize that these techniques are not shortcuts. They are core math skills. It's just as important to be able to use substitution or another technique to manipulate your problem so that it's easier to solve than it is to be able to solve a difficult problem.
It's definitely more useful than I realized. When you and I were first talking about having you come on and guest host an episode and you said you wanted to talk about substitution, I definitely thought, substitution? You mean the algebra strategy? Thinking, how are we going to have enough to talk about here? But I didn't realize how critical substitution was in a lot more than just algebra. And what you have to realize is that you can do a lot of these things without substitution. It's just going to take you a lot longer. Just like your student may have had trouble with that more complicated addition problem. Now you've made it easier. Right. And just like you're substituting for Pete at all of his jobs, and it's taking you a lot longer to do all these jobs that you thought it was going to take.
Pete does not have a life that I consider easy.
No, he doesn't. Well, maybe right now at the moment because he's on vacation and we're here in the math club. But other than that, I think you're right. Is there anything else about substitution that you wanted to mention, or do you think we about covered everything that you wanted to talk about?
There is so much more to talk about with substitution. but I think that should cover it for this episode.
Okay. But before we wrap this episode up, I believe we have a puzzle to share with our listeners.
Oh, right. And this puzzle will challenge them to use their substitution skills to find the right answer.
So you may want to write some of these details down, Math Club. Or if you'd prefer to read them, we've set up a web page where you can read the puzzle and submit your answer. You can find that at bit.ly/mathclubpodcast-puzzle4. And we'll also put that link in our show notes. Ready for the puzzle? Here we go.
4 friends, Dan, Jennifer, Kenny, and Sarah, want to figure out how much they each weigh. They don't have a scale, but they do have a 2-sided balance. And between them, they have 3 pets whose weights they already know. The bulldog weighs 120 pounds. The pig weighs 40 pounds. And the cat weighs 10 pounds. They decide to use the balance and what they know about the animal's weights to try to figure out their own weights. So they run some experiments and find that the scale is balanced for the following 4 situations.
First, the 2 sides start off balanced with Dan and Sarah on one side and Jennifer and Kenny on the other. Second, the cat jumps up into Jennifer's arms, and to rebalance the scale, Sarah and Kenny have to switch sides. Third, now Dan and Sarah switch sides, and to rebalance the scale, Dan picks up the pig. Fourth, finally, the scale is balanced one last time with Jennifer alone on one side and all 3 pets on the other.
So, using all this information, can you figure out how much each person weighs?
The first person to send in the correct answer will get a shout out on our next episode.
And how do they submit their answer once they've figured it all out?
Well, our favorite way to hear from you is to hear your voice. And to that end, you can leave us a voice message on our SpeakPipe page. To do that, just go in your browser to speakpipe.com/mathclubpodcast, and you can record us a voice message. Of course, you can also use the webpage that we mentioned a few minutes ago to read the puzzle and submit your answer there. Again, that link is bit.ly/mathclubpodcast-puzzle4. You can also reach out to us on Twitter. We're the one account that's still there, and our handle is @mathclubpodcast. Or you can send us an email. Our email address is mathclubpodcast@gmail.com.
Sounds great.
Well, Pete, thanks for coming in and being our substitute Pete, our substitute co-host, and teaching us all about how to substitute in math. It was a pleasure having you.
You know, I'm sure there's some type of method I can apply to that last sentence to make it a lot simpler.
I'll bet there is. All right, we'll see you next time, Math Club.